Welcome. Today I'm going to be giving you a brief overview of Chapter 1. Chapter 1 is divided into 3 sections. The first section talks about the history of psychology and talks about various different people that were important in the history of psychology as well as their ideas. First it goes over the early forerunners of psychology, and then later it brings up the more modern people and their theories. There's a chart over the modern people and their theories covering 6 major theories that still are in existence today. Then the second section of Chapter 1 goes over psychologists and what they do, and specifically goes over their specializations. And there's also a chart in your book showing all the different specializations of psychologists. Most psychologists, in fact, end up going into clinical psychology, where they're doing private therapy with individuals, trying to help them with various different problems. But other psychologists go into other fields. My own specialization in psychology is experimental psychology. And there are a number of emerging fields as well coming up in psychology that are all really fascinating, like sports psychology, forensic psychology, where they're studying criminal cases and all of that, studies of aged individuals and their needs, gerontology in other words. So there are a lot of new fields too that are emerging. All right, then the third and final section of Chapter 1, I really spend a little more time on that section. And the third section of Chapter 1 talks about how we do research in the field of psychology. And the interesting thing about doing research in psychology is that virtually any science does research the same way. We follow the same methods. We use the same methods to avoid bias. We analyze our results with the same statistical mathematical measures. And so when you learn something about how to set up psychological studies in psychology, really that overlaps to many, many other fields, whether you're in engineering or medicine or many other fields, use the same basic research principles. All right, some people say to me, is psychology a science, or what makes psychology a science? In fact, what makes psychology a science doesn't have to do with what we're studying, it has to do with the way we study it. So again, it doesn't matter whether you're studying human behavior or whether you're studying chemistry or biology or physics, it's the way you study it that makes something scientific. If you follow rigid scientific principles in the way you set up your studies, then it's a science. And the scientific method is discussed in Chapter 1. Also, then, let me talk about some of the ways we set up our studies, and there are many, but I'm just going to mention a few today. One of the things we can do is we can either take our study out into nature, called a naturalistic study, or we can bring it into the lab. Naturalistic studies have their advantages, whether we're watching animals or whether we're watching children on the playground, because people and animals are more likely to act natural out in their natural environment than they are if you're having them being tested in a laboratory. Laboratory studies, of course, also have their advantages in that we have so much control. We can control the lighting, the humidity, the noise levels, many factors, so that we can be sure that it's our experimental treatments that's making the change in behavior rather than just something random out there that happens. All right, then, further discussing how we set up our studies. There are different kinds of ways we can set up our studies. Early studies in psychology tended to be case studies, where you follow a single individual and study them in great detail over a long period of time. Or you could study a small group of people and follow them over a period of time. We still do case studies today, but more commonly we're going to do other types of studies like correlations or experimental studies. Correlations are where we look to see whether or not variables are related. 2 or more variables are related. And a positive correlation would be when 2 variables are heading in the same direction. They're either both going up or they're both coming down. An example of that would be cigarettes and lung cancer. I think we all know that if you smoke more cigarettes, your probability of getting lung cancer also increases. So they're both moving in the same direction. Correlational studies also sometimes reveal that variables are heading in opposite directions. That is, when one goes up, the other one comes down. Like with exercise and heart disease. You exercise more, you're less likely to have heart disease. Also, sometimes when we run a study, we find out that there's no connection at all. There's no relationship at all between the variables that we're studying. Let's say that we predicted that head size had something to do with intelligence. We said the bigger your head is, the smarter you are. And we could actually run that study, passing out a tape measure, having each person measure their noggin, and then passing out an IQ test, and we could see if there was any connection. But I'm guessing if we did run that study, we'd find that there is no relationship at all. There's no correlation. Bigger head people are not smarter than little beanie head people. We're pretty much all alike, and it's just pretty random. All right, so that's correlational studies. You have to be careful with correlational studies. What we do know from correlational studies is that you can predict one thing from another. You can predict B from A. But what you have to be careful about is when you take that extra step and try to say that because you can predict B from A, that means that A is causing B. Yes, they are correlated, but you can't always be sure. Sometimes A is causing B, but other times B is the one that's causing A. They just happen to be correlated. And other times it's a third factor yet that's sneaking in there and causing both of them. So with correlations, you have to be very careful if you're going to take that extra step and try to say something about cause. Now with true experimental studies, you can talk about cause because of the way the study is set up. With a true experimental study, the first thing we do is think about what problem we're interested in studying. Maybe we're interested in studying test anxiety and students. And so once we've decided upon our problem, we're going to think about what population we want to test. And let's say we just want to restrict our study to college students, and so that's going to be our population. Well, clearly we can't test all college students in the world or even in America. And so what we're going to need to do is draw out a sample of students from that larger population to test. The most important thing about our sample is that it represents our population, so it should look like our population. You know, people of different ages and genders and races and whatnot. And so the very best way to get a representative sample is to randomly select people for our sample from the larger population. All right, once we get our sample in place, then we're going to split our group up typically into a treatment group and our control group. And the treatment group is going to get our marvelous new treatment for test anxiety, and the other group, the control group, is there just to serve as comparison purposes. All right, in this particular case, the treatment that we're going to administer is called the independent variable. The independent variable is the one that we can manipulate as an experimenter. We can give it to them, not give it to them, whatnot. And so the independent variable is the one that we have control over. The dependent variable is the effect, whatever effect we're interested in studying. In this particular case, we're interested in looking at the effect of test anxiety. Did they have more test anxiety, less test anxiety, and so on. And so we're going to measure their levels of anxiety after we give the treatment, and we keep our control group there as comparison. And then when we finish up the study, we're going to compare the average level of test anxiety in our treatment group and the average level of test anxiety in our control group and see if there's a significant difference between them. So then we can go out and say, yes, our therapy works, or no, in fact, it doesn't. Finally then, from this chapter, I want to mention ethics. Whenever we're working with animal or human subjects, all scientists adhere to very rigid standards of ethics. Today I'm just going to mention a few ethics having to do with human participants. Whenever you have humans in your study, the very first and most important thing really that you need to remember is that you're not allowed to harm your subjects. You can't harm them physically and you can't harm them psychologically. Now you could ask them to skip a meal or a night of sleep, but you cannot do anything that's going to cause them any serious or lasting harm. And that sounds real simple, just don't hurt people. But in fact, things do come up once in a while. Even in my own research, I remember doing a study involving a medical school and another university, and we were giving caffeine to students, and then we were taking their blood pressure and their pulse, and we're giving them really fast memory tests. And this one girl came up front, and she didn't mention to us that earlier in the day she had donated blood, like to the Red Cross or something. So when they put the blood pressure cuff on her and they pumped it up really tight, that little hole popped back open and she started gushing blood. Much to all of our surprise, we don't even know why she's bleeding. So all you can do is your best. You try very, very hard to think of anything that could possibly hurt your subjects, and you have them sign all these consent forms and all of that. All right, secondly then is informed consent. Before an experiment starts, you want to tell your participants everything about an experiment that might make them not want to do it. If they're going to be hungry or cold or stressed out, you want to tell them ahead of time. Because we have found that once an experiment begins, subjects almost never drop out. The next principle I want to mention is deception. Yes, surprisingly, most people are very surprised by this. We can use deception when we're doing an experiment. Most of the time, they'll deceive people because they're afraid that if they told them the real purpose of the study and all that, it might bias the way their participants are responding. What you cannot deceive them, though, about is something that might make them not want to do it. You'll say, well, I just won't mention that because otherwise they wouldn't be in the study. No, you can't do that. But you can deceive them about things that really wouldn't affect them in any way in terms of harm. All right, but if you do, before they leave, you've got to debrief them and tell them all about it and why it was necessary to deceive them. Next, I want to mention, and finally, in fact, I want to mention privacy. Whenever you collect data about an individual, you are absolutely obligated to maintain their privacy. You cannot, well, you are allowed to share information about the whole group and their averages, but you're not allowed to share information about single individuals. Even if that information seems good, like maybe you find out that Billy's a genius. Well, you know, maybe Billy doesn't want people to know that he's a genius. Maybe Billy's parents don't want people to know that either. So we're obligated to keep that information private. All right, that's all I'm going to mention about Chapter 1. I did give you a study guide with further words that you can cover to help you prepare for your test, but that's all for today on Chapter 1.